So in this video, we're going to talk about concavity and the second derivative test. So what is concavity? So we've got a function here, f, and we say that this function is concave up. Now, why is it concave up? Well, as x increases, so as x gets bigger and bigger and bigger, what's happening to the derivative? Well, the derivative, here it looks like the derivative is negative, and then here looks like my derivative is 0, and then here looks like my derivative is positive. So I'm going from negative to 0 to positive, so it looks like my derivative is increasing as x increases. Okay, so this is the idea of concave up. As x increases, the derivative increases. One way to remember it, it holds water. So what do I mean by that? If like water was pouring down here, water would get held in this, right? So it holds water. Now, another way to remember concave up is like a cup, all right? So it's kind of like a cup. You can fill it up with water, right? So that's the idea there. Concave up is like a cup. It's kind of silly, but it's a good way to remember concave up, like a cup. Okay, now this one here, well, if this was concave up, guess what this is? This is going to be concave down. Concave down here, as x is increasing, so as we go this way for x, this looks like the derivative is positive here. When I get up to here, the derivative is 0, and then whenever I increase x over on this side, I get a negative derivative. So as x increases, my derivatives go from positive to 0 to negative, so they're getting smaller, they're decreasing. So as x increases, the derivative decreases. Okay, so this is the opposite of concave up. Instead of increasing derivative, the derivative is decreasing as x increases. So it repels water. What does that mean? That means like when water is coming down, it just runs off the side. It doesn't fill up like a cup like this one does. Okay. One other way to remember it is concave down is like a frown. Concave up is like a cup. Okay, so those are just ways that will help you memorize concave up, concave down. Now, we are interested in what? We were interested in how the derivative is changing, okay? So as x changes, what we're analyzing is how does the derivative change? Whereas when we were talking about increasing and decreasing functions in the last section, we were interested in how the function f changes. Now we're interested in how the derivative changes, okay? So that means for us to gain more insight on the function f of x, we need to study f double prime of x, okay? When you think about the derivative is how f changes, well, if we're going to study f prime, we need to see how f double prime changes, or how f prime changes, which is f double prime, okay? So we're just going one more layer into the rabbit hole. Now, concave up, concave down. Definition: let f be differentiable on an interval. The graph of f is concave up if f is increasing. As this shows here, if f is increasing, then we're concave up. And the graph of f is concave down if f prime is decreasing. So here, f prime is decreasing here. It's go from positive to 0 to negative. For concave up, f prime is increasing. We're going from negative, positive to, or from negative 0 to positive, right? So we're increasing there. All right. If f is constant, then if f prime is constant, then the graph of f is said to have no concavity. All right, so if I have a graph and it's just like horizontal constant line, then it's not concave up, it's not concave down, okay? Test for concavity. So how do we test for concavity? We let f be twice differentiable on an interval. The graph of f is concave up. If the derivative, the second derivative, is positive, and then the graph of f is concave down if the second derivative is negative, okay? So just like with the increasing, if the derivative was positive, we were increasing, f was increasing. If the derivative was negative, then f was decreasing, okay? So the second derivative tells us, are we concave up or are we concave down? So how does this work? Concave up, I put little smileys here. I know this is goofy, but this is how I remember it. Positive, I'm smiling all the time, right? So concave up, we're positive, we're smiling. The derivative of the derivative, the second derivative, is positive. And if it's positive, I'm concave up on that interval. All right, smiling. Now concave down is like a frown. What do we do when we're negative? We frown, right? So negative, f double prime is less than 0. We're frowning, we're negative, we're sad. So f double prime is less than 0. This is when we're sad. Okay, I know it's goofy, but this is an easy way to remember it. When you're looking at the second derivative, if it's positive, we're smiling. If it's negative, we're frowning. All right, concave down looks like a frown, right? And concave up looks like a cup. Okay.